Hello guys, today we're going to learn about properties of exponents. This video you can use for both assignments 2 and 3. Assignment 2 is a little bit more simplistic than assignment 3, and assignment 3 is, the idea behind it is to challenge you a little bit. So let's get started. First thing that we're going to talk about is the product of powers. So what happens when you multiply two variables that are raised to a power? Let's say x squared times x to the third. So what this really says, if I expand it out, x squared is x times x, and then x cubed is x times x times x, and they're all multiplied together. So what I really see here is actually 1, 2, 3, 4, 5, or x to the fifth power. Now how did they get that? Well, they added the two exponents together. So whenever you're multiplying two variables that have, and they have to be the same variable, so you need the same base for your exponents, x squared times x to the third is the same thing as x to the 2 plus 3 power, which would be x to the fifth. So when you're multiplying, you're going to add your exponents, okay? So that would be a good thing to make a note of. What would change there if I, what would change if I write 3x squared times 4x to the fourth power? So you're still multiplying, so keep that in mind. So if you see an actual number, a coefficient, you're really multiplying those. So this is 3 times 4, and then it's x to the 2 plus 4 power, because we're multiplying the x squared times the x to the fourth, and that's when you add your exponents. So this whole answer becomes 12x to the sixth. The next one we can look at is power to a power. And so that's when you have something like x squared raised to the third power. So what this is really telling us is that we have x squared times itself 3 times. So if I expand it, it's x squared times x squared times x squared, which again expanded is x times x times x times x times x times x. So you see we have 6, so x to the sixth. So when you see a power to another power, when you see the parentheses and then they're on different levels, that's when you're going to multiply your exponents. Now if you see something like negative 2 x squared raised to the fifth power, let's say, if there's more than one item inside of your parentheses, so there's multiple things that are multiplied together, for example, negative 2 and x squared, and they're raised to the power, what this really means is that everything inside of the parentheses is raised to the fifth power. So not only are we going to do negative 2 to the fifth power, we're also going to do x squared to the fifth power. Really, really important that you remember that. That's a huge thing that people make a mistake with. And then you just want to calculate each part separately. So negative 2 to the fifth power, well, a negative to an odd power is going to stay negative. And 2 to the fifth power is 32. And then x squared to the fifth, well, we said when it's a power to another power, we're going to multiply. So 2 times 5 would give us x to the 10th. All right, the next thing that we can talk about is a quotient of powers, or when you're dividing two powers. So let's say we have x to the 6th divided by x to the 4th. And let's expand it out to see what happens. Well, x to the 6th is x times x times x times x times x. 1, 2, 3, 4, 5. times x divided by x times x times x times x. So when you're looking at variables, just like with numbers, if you have 5 divided by 5, well, that's the same as 1. Those cancel out. When I have x divided by x, that's the same as 1. They cancel. So I can go down and cancel all of these different things, and what I'm left with is x to the second power. Well, when you look at the numbers 6 and 4 and say, how did they get a 2 out of that? All they really did was subtract their exponents. So when you see division, when you see a quotient, you're subtracting the numerator's exponent by the denominator's exponent, and that gives you your answer. So divide is the same as subtracting exponents. All right, and again, you want to make sure you have the same base. So x's go with x's, y's go with y's, etc. Negative exponents can get a little bit tricky and they freak some people out, but there's nothing to worry about. So a negative exponent, what that really is telling you is that it's on the opposite side of the fraction where it wants to be. So x to the negative 2 power, well, right now it's x to the negative 2 over 1. And when we simplify, we want to make powers positive. Well, in order to make this a positive exponent, I just have to move the whole x to the negative 2 down to the denominator, and then your power becomes positive. So you're moving the entire thing, just that component, just that piece, and it becomes a positive power when it's shifted. So you're just swapping it either above or below your fraction bar. If you have 1 over x to the, let's make it 3x to the negative 5th, well, this would be the same thing as taking the part with the negative exponent and shifting it up. So x to the 5th over 3 would be our actual simplified answer. Another thing we can work with is the power of 0. Anything raised to the 0th power is the number 1. No more variables, just the number 1. Even if you have a big giant problem like 2x to the 4th z squared over xyz, and it's all raised to the 0th power, the whole entire thing equals 1. And you can do all the simplifying you want, but it doesn't matter as long as this entire fraction, or whatever's in parentheses, is raised to the 0th power. Another thing about quotients, which I forgot to mention before, if you have something that's being divided, like x over x squared, and it's raised to a power, that power goes with both parts of your fraction. So this is really the same thing as x to the 4th over, and then the second power to the 4th power, so it's x squared to the 4th power. So we get x to the 4th over x to the 8th. And then simplifying that, well, when you subtract your exponents there, 4 minus 8 would actually give you x to the negative 4. But we don't want to leave our answer with the negative, so we make it 1 over x to the 4th. The other way you can think about it is that there are more x's in the denominator than there are in the numerator. So as you cancel x to the 4th and x to the 8th, you're going to be left with just 4 x's in your denominator. So 1 over x to the 4th is what you would have. So let's do one last example where there's a lot going on, and then you can try some practice with assignments 2 and 3. So the first thing that I want to point out is that we have a number. All right, if there's another number in the denominator, you want to reduce your fraction just like normal, but you don't subtract because these are not exponents. All right, so technically there's a 1 here, and we can always write that in if we don't see it. So I'm going to start out my problem by keeping the 3 because there's nothing to reduce it with. And then I want to see what I can simplify. Any negative exponents, I'm going to bring up or bring down so that those exponents become positive. So the first thing I'm going to do is take x to the 4th and bring it up, so that up here we have x cubed and then positive x to the fourth. And then I'm going to take y to the negative 1 and z to the negative 1 and bring them down. So on the bottom we have 1, and then we have y to the 0, z to the 0, y to the positive 1, and z to the positive 1. Now everything's positive, so I can begin simplifying. So my next step would be to say, all right, well, anything to the 0th power is just 1. So those two are canceling each other out. And so my fraction is now 3x cubed, x to the 4th, over, and that's a times in between if you need that, 1 y z. And I don't need to write the first power because if it's nothing there, I assume it's a 1. The only other thing we can combine are the two x's. Right? So same base, we can put them together. It's multiplication, so I'm adding my exponents. So 3x to the 7th divided by y z. And there's a million different ways you can go about simplifying this, but you just want to make sure you're following all of your rules and you will be all set.